All right, here we are continuing on with our polynomial zeros. So we're going to identify possible zeros, and of course we're going to solve them. So today we're going to talk about what's called the rational zero theorem. And what this rational zero theorem will help us do is it will help us go ahead and find specific values to test. Instead of just testing any of them randomly, we're going to focus in on certain ones. We're going to look at the constant term, the number at the very end, and the leading coefficient term. And those two numbers will help us go ahead and decide what numbers we should try into our synthetic division. For example, here's negative 40. Well, what are some numbers that multiply to negative 40, or factors of them? So 1 is, 2 is, 4 is, 10 is, 5, 8, 20, 40. Those are the only ones that can possibly be answers to this. So 3 cannot be a possible answer because it doesn't go into 40. So this will limit what we have to go ahead and do. Now, any kind of leading coefficient can go ahead and divide those numbers that we just listed out. So let me show you with some different examples. So here, looking at this one, our last number here is 4. Well, what are the possible values of 4? 1, 2, and 4. The first number is 3. So our values are 1, 2, and 4, and the other values are 1 and 3. So it's the combination of these in the numerator with these in the denominator. Now, a lot of times we will not have that leading coefficient, so we're just looking at these values here. But if there is a leading coefficient, we can get some fractions. So what can we have? Well, we can have 1 over 1, or 1 over 3, or 2 over 1, or 2 over 3, or 4 over 1, or 4 over 3. And so those are the different values that are all listed here, and those are the only answers that can possibly work into our synthetic division. So if you wanted to go ahead and try 3, or you wanted to try 5, I can tell you already that it won't work because these are the only ones that are possible. So this greatly limits down what we're doing. And that with Descartes, you can go ahead and limit whether they're positive or negative too, and just going ahead and getting much more focused in on the possible numbers that we can put into our synthetic division. So let's look at another one. Notice this one has no leading coefficient, so we're only looking at these numbers. Well, what multiplies to give us 15? What are our possibilities? There's only a few of them, 1, 3, 5, and 15. This kind of problem, to solve it, those are the only numbers we have to look at. Any other numbers will not give us an answer that's a 0. All right, so what about this one? We have a 6, which is 1, 2, 3, and 6. But this 2 here has to be able to divide, so we can divide them all by 1, or we can divide them all by 2. If I divide them by 2, we get 1/2. We're going to get 1, which we already have, 3/2, and 3. So 1/2 and 3/2 have to be added on, so it's the C value. What about this one? No leading coefficients, so we're just looking at the 24. So what multiplies to give us 24? 1, 2, 3, 4, 6, 8. So these are the only numbers that we should have to try. All right, so let's try some actual problems. All right, here we have an x to the third. We're going to have 3 answers to go ahead and work here. So I'm going to start with Descartes. So 1, 2, negative 8, negative 121. If you notice, there's only one sign change, so only one positive value. If I put the negatives in here, this is negative 1, 2, 8, and negative. That's a positive 8 there that time. So there's 2 or 0 zeros. So we need to go to our synthetic division. So we have positive answers. So we have a positive 1 answer here. That's where we want to go with. We don't want to go looking for here in case there's nothing. That way we don't miss it. So we're looking at our positive values. Now let's look at this number here. Well, what can go into this number? Well, 1 can, and 2 can, 5, 10. These kind of numbers would go into this. So we started with 1, and we didn't get much movement, and 2 didn't give much movement. So we jumped ahead to 10, because 10 will go into this number. And sure enough, 10 worked, so then I'm done. I don't have to go any further. So I have 10, I have a quadratic left. So I put that quadratic because I don't know anything that multiplies to 112 that adds up to be 12. So just trying the quadratic. 144 minus 4 times 1 times 112, which is negative 304. which is 4i root 19 when you go ahead and birthday cake it. So then we put it in opposite of b, which is negative 12 plus 4i square roots of 19 over 2. Divide everything by 2, and we get negative 6 plus 2i square roots of 19. So there's my two answers. So there were no negatives, so we would have been up the creek if we went that way. And we had our 10 value here. Notice we didn't try 3 and things like that because it doesn't go in. We don't have to. So just try the numbers that will divide into this value here at the end, and that will help us focus in on what numbers to try. All right, here's another one. This one's going to have 4 answers. All right, so we know we have 4 different values. So let's do the Descartes. So we put the 1 in, and we get 2 or 0. So 2 or 0 positive, and 2 or 0 negative. So that doesn't help us much either way. So we're just going to have to start it off. Kind of looking at our zeros that we can have. Here's 30. So what goes into 30? 1, 2, 3, 5, 6, 10, 15, and 30. So these are the numbers we're going to try. You should never try 4. You shouldn't try 7, 8, those kind of numbers. These are the only ones that are possible answers. All right, so let's go ahead and do a table and start it off. So the 0 here is 30 as an answer. So if we try 1, we get 24. So it's coming down. Try 2, and we get our 0. So we were able to go ahead and find 1. But this is since it's a 4th degree, we only have a 3rd degree left. So I can't go ahead and put this in the quadratic formula or factor this yet. So I'm going to have to keep going. So this is what's left. So I'm going to have to go ahead and keep going with my zeros. Well, I found a positive 0, so that means I need another positive. So I can go try 3, and lo and behold, 3 works. And I'm left with 1, 6x, and 5, which I can go ahead and factor. What multiplies to 5 that adds up to be 6? Well, 5 and 1. So here I have that. I factor into 5 and 1, solve each of those, and I get negative 5 and negative 1. So I've got these 2 answers plus the other 2 I've already found. So negative 5, negative 1, the 2, and the 3, which will go ahead and give us our 4 answers. All right, let's try another one. This one also has 4 answers. All right, so I do Descartes again, and I get 2 or 0 for both of them. I have a 45, so what number should I try? 1, 3, 5, 9, 15, 45. Those are the only possibilities, plus or minus. So let's just start with the plus. The first one is 0, and that gives me 45. So I want to try 3 because it's kind of in the middle here. That, if it gives me something, it can tell me which way to go. So I tried 3, and I got 0. Great. That worked out well. So now I go from this value here. I ignore the top here, and I go from this value. So I went ahead and tried the next one up, 5. And I got 320. Okay. And remember, this is now a 0, like the first one, as I'm rewriting it. So 0 and 5, there's a sign change between 0 and 5. Well, I already know that 3 was an answer, so I'm going to try 1, and 1 does go ahead and work. Then I'm looking at what's left here. I don't have to quadratic formula because it is it works out. 2 numbers that multiply to 15 that add up to be 8 are 3 and 5. So I have negative 3, negative 5, and the 1 and the 3. They both give me zeros. And that's what I have for you today.